Welcome back to the Explainer. Today we're diving into something pretty cool, a programming language called Omicron. Now what makes it special is its whole philosophy, which is all about making code, intuitive. It really boils down to one powerful question. So let's get into it.
You know that feeling, right? You look at a page of code for the first time, and it's just a wall of symbols. It can feel super intimidating, really complex, just cryptic. But what if it didn't have to be like that? What if a programming language actually tried to meet you halfway?
Well, that's pretty much the exact question a language called Omicron is trying to answer. And honestly, it announces itself with this really enthusiastic, kind of quirky declaration. You can just feel it, right? This isn't just a bunch of commands. This is code with some personality. It feels like it was designed from the get-go to just make sense. Okay, so here's the plan. We're not going to try to become Omicron experts today. Instead, let's think of it like we're climbing a coding ladder, just to get a feel for its core idea. And we're going to start right at the bottom, on the very first rung, with the absolute basics. All right, first rung of the ladder, the basic commands. We're talking about the absolute fundamentals here. These are the building blocks for, well, pretty much any program you could ever write. Okay, check this out. This is where you first see how Omicron is different. The very first thing you learn in programming is how to make the computer show you something, right, an output. But instead of some technical jargon, Omicron's own definition is in Hinglish, a mix of Hindi and English, and it just means show on screen. How simple is that? It's so direct, you get it instantly. And here's what that looks like in practice. This is the classic hello world that every programmer starts with. See, there's no crazy setup, no complicated boilerplate. It's just the output command and what you want to show. It literally does exactly what it says it's going to do. Okay, next up, a program needs to be able to remember things. And again, Omicron keeps it super simple. A variable is just a way to store a value. That's it. You can think of it like a little labeled box where you can stick a piece of information that you're going to need later on. And just look how clean the code is. Let x equal 10. That's it. We're just creating our box, we're calling it x, and we're putting the number 10 inside. This simple idea, defining something so you can use it later, it's fundamental to all programming. Of course, those little boxes we talked about can hold all sorts of different information. And Omicron covers all the essentials. You've got your numbers for doing math, you've got text for words and sentences, booleans, which are basically for simple true or false questions, and you even have a special value for when there's nothing in the box at all. All right, let's climb up to the next rung on our ladder and see how this all starts to build. Now that we can store stuff, the next step is to make our code a little smarter. We need to give it the power to make decisions, and maybe more importantly, to repeat actions, so we don't have to write the same line of code over and over and over again. So here are the two main ways a program can make a choice. First, you have an if statement. Think of it as a simple check. It'll only run a piece of code if a certain condition is true. But then you have if-else, which is way more flexible. It gives the code two paths to take, one if the condition is true, and a completely different one if it's false. Let's actually see that two paths idea in action. The program checks a condition. In this case, is 5 less than 3? Well, no, that's false. So the code completely skips the first part and follows the else path, showing us the word hi. It's just a simple, logical fork in the road. But what if you need to do something, say, 5 times? You're not going to write the same code 5 times, right? That's where loops come in. And Omicron's term for this is just so direct. Run a range. It's an instruction, plain and simple, to repeat an action for a specific sequence. So what's really going on inside a loop that runs from 1 to 5? Well, it sets up a little counter, I, and starts it at 1. It runs the code inside the loop. Then it bumps the counter up to 2 and runs the code again. And it just keeps doing that, all the way up until it hits 5, and then it stops. Simple as that. Okay, so we can store single values, and we can make our code make decisions. That's great. But what happens when you have a whole bunch of data, like a list of names or a list of prices? You need better ways to keep all that organized. And that brings us to the next rung on our ladder. So Omicron gives you a few different tools for organizing data. A list is basically like a shopping list you can add to or cross things off of. A tuple is kind of similar, but once you make it, it's locked in stone. You can't change it. A set is like a guest list for a party. No duplicates allowed, everyone is unique. And a map is like a dictionary, where you pair a key, like a word, with its value or its definition. Each one is a specific tool for a specific job. Okay, we're getting near the top of the ladder now. We've got all these individual tools, which is awesome. But to build something really big, something complex, you need blueprints. You need ways to package up your logic into reusable chunks that you can use whenever you want. And that is exactly where functions come in. A function is really just a named block of code that does one specific thing. You define it once, and then you can call it by name as many times as you need to. It's kind of like a recipe, right? You write the recipe down once, but you can use it to cook that dish over and over again. And this is what makes functions so powerful. Look at this. You can define a little piece of logic, like how to add two numbers together just one time. And from then on, you can just call that add function by name whenever you need it. It saves you from rewriting that same logic again and again. And finally, we get to classes. Now, if a function is like a recipe for an action, a class is like a blueprint for an entire thing, an object. It lets you define what that thing is, what it knows, and what it can do, all bundled up together in one neat package. So here's a super simple blueprint for a dog object. All it says is that any dog object we create from this blueprint will have a name, and that name will be text. From here, you could add functions right into the class, like a bark function, and you'd have this complete, self-contained little unit. So we've pretty much climbed the main ladder here, but Omicron is a totally full-featured language. I mean, it's got tools for all the modern stuff, like talking to the web or running tasks in the background so your app doesn't freeze. It also has powerful ways to organize your code and, really importantly, to handle errors when things go wrong. It's a whole toolkit. So after this quick tour, what's the big idea here? What's the takeaway? You know, the real innovation isn't any single feature we looked at. It's the whole philosophy behind it. It's this relentless focus on clarity, on simplicity, on using natural, understandable language to explain concepts that are usually buried in technical jargon. And that really leaves us with a pretty fascinating question, doesn't it? Omicron shows us one possible path forward. In a world that is completely run on code, shouldn't we be working harder to make that code understandable to more people? Maybe the future of programming isn't just about being more powerful, but also about being more approachable. Definitely something to think about.